having similar intermolecular attraction forces. Okay, and they have a similar molecular sizes also. They're having similar molecular sizes. So what are the examples of the ideal solutions means? Let us see. So in examination, how they're asking the questions means they'll give some of the examples. From that one, we have to find out whether the given example is obeys the Raoult's law or ideal solution or non-ideal solution. So examples are very, very important. Okay, what is the condition I'm telling that? So molecular has molecule solute and solvent, it has to be similar molecular size, similar intermolecular attraction forces, it has to be there. So what are the examples for the ideal solutions means here? Benzene and toluene. Benzene and toluene are the examples of the ideal solution. N-hexane, N-heptane, chlorobenzene, bromobenzene, ethyl chloride, ethyl bromide, and ethyl iodide. Ethyl bromide and ethyl iodide, N-butyl chloride, N-butyl bromide. So all these are the examples of ideal solution. Okay. Then what is with the non-ideal solutions? Exactly opposite, ma'am. So what is with the non-ideal solutions? The solutions which does not follows Raoult's law, wide range of concentrations is called as a non-ideal solutions. The solutions which does not follow the Raoult's law, wide range of concentrations is called as a non-ideal solution. For non-ideal solution, delta H is not equal to 0. Delta V is not equal to 0 for non-ideal solutions. For non-ideal solutions, delta H is not equal to 0. Delta V also is not equal to 0. Again, based on the intermolecular attraction forces of the solute and solvent, non-ideal solutions are classified into two types. Okay, so one is called as a positive deviation non-ideal solution, and second one is called as a negative deviation non-ideal solutions. Second one. Negative deviation non-ideal solution. So again, non-ideal solutions are classified into how many types means here. So non-ideal solutions are classified into two types. What are the two types means? One is the positive deviation non-ideal solution and negative deviation non-ideal solution. Okay. Now shall we see the difference between the positive deviation non-ideal solutions and negative deviation non-ideal solutions?
Yes,
okay.
sir.
Right. Now let us see. So here, positive deviation non-ideal solution. Okay, so already we know the characteristics of the positive deviation non-ideal solutions. Now, for the positive deviation non-ideal solution, AB is nothing but solution. Solution is having the weak intermolecular attraction forces by comparing with the solute and solvent. Okay, solution, positive deviation non-ideal solution, okay, is having the less intermolecular attraction forces while comparing with the solute and solvent. Simple example. Before that, I'll give one example. Now my question is here, ethanol. Alcohol is having some boiling point temperature na? All of you, is alcohol is having some boiling point temperature or not?
Yes, sir.
Water molecule is having some boiling point temperature. Actually, what is the boiling point temperature of the alcohol? Water? 100 degrees centigrade. What is the boiling point temperature of the water means here? 100 degrees centigrade. Okay, you got my point or no? Next, let us consider ethanol is having some 70 degrees centigrade of the boiling point temperature. What is the boiling point temperature of the ethanol means? We can consider it as around 60 to 70 degrees it is there. Okay. Now, both are having different boiling point temperature. But when you dissolve the alcohol into water, When you dissolve the alcohol into water, the boiling point temperature becomes as 100 degrees centigrade for the both the solutes, both the components. You got it or not? My point. All of you got the clarity or not? Ma. So alcohol boiling point temperature is 60 to 70 degrees Celsius. Water boiling point temperature is 100 degrees centigrade. First point you understood? Everyone? Srisha?
Yes, sir.
Yes, sir.
Ritu? Okay. Now, my
Yes,
second
sir.
condition, when you dissolve the alcohol in the water, and one more thing also clearly we can say. So actually alcohol is highly volatile. Alcohol is highly volatile. When the alcohol is placed in the water, it does not evaporate fastly. It evaporates very slowly. Why, sir, it does not evaporate fastly means here, when you dissolve the alcohol into the water, okay, it becomes as a uniform solution and it shows the positive deviation. Sir, what is meant by the positive deviation means here, whenever you add the water to the ethanol, okay, it decreases the intermolecular attraction forces in between the solute. It decreases the intermolecular attraction forces in between the solute. So before that one, if you add without adding the water, okay, alcohol, so ethanol is having the intermolecular hydrogen bond. Okay, it has an intermolecular hydrogen bond. So whenever you add the water molecule, it decreases the interaction between the solute molecule. In between two ethanol molecules, interaction is going to be decreases. That time what happen? Automatically boiling point temperature is going to be increases. Sir, why the boiling point temperature is going to be increases means, and behalf of the interacting with the ethanol, it interacts with the water molecule. That means it forms as a more bonds with the water molecule. Number of hydrogen bonds are increases. Their boiling point temperature also is going to be increases. So due to that reason only, ethanol and water also boils at 100 degrees centigrade. Okay. So you got the clarity. So whenever from low to it is boiling at high temperature. Actually, ethanol is having what is the boiling point temperature? 60 to 70. But after dissolving in the water, it boils at 100 degrees centigrade. The boiling point temperature is going to be increases or decreases? The boiling point temperature is going to be increases or decreases after dissolving in the water?
Increases?
Ma, before that 60 only, na ma. So sorry, I didn't write na. So to make you understand, ma, what I am telling that first we are taking as a ethanol, ma. Ethanol. What is the molecular formula of the ethanol? C2H5OH. The boiling point of the C2H5OH is 60 to 70 degrees centigrade, ma. Water boiling point temperature is 100 degrees centigrade, ma. Whenever you dissolve the ethanol into the water, then the boiling point temperature becomes as 100 degrees centigrade. You got the point now here, all of you? Okay. So it becomes as
Yes, sir.
alcoholic water. Now the boiling point temperature becomes as 100 degrees centigrade. Now you can check it out. Before dissolving in the water, boiling point temperature is 70 degrees. After dissolving the ethanol into the water, the boiling point temperature is 100 degrees. So 70 to 100, it becomes as a 70 to 100 means boiling point temperature is increases only na. Okay.
Yes, sir.
Yes, sir.
The boiling point temperature is going to be increased. Okay, so why it is increases means because of solute interactions, it will be more solute and solvent interactions are more than that of the solution. Solution is having the weak intermolecular attraction forces. Okay, now if it is having the weak intermolecular attraction forces, easily it is converted to the gaseous form now. That means at 100 degrees centigrade. At 100 degrees centigrade, if you take separately, if you take separately means your ethanol also it is converted into the vapor form, water also it is converted to the vapor form. Both are converted into the vapor means then vapor pressure is going to be increases or decreases. For example, the vapor pressure of the ethanol we are considering it is as a PA. Okay, the vapor pressure of the water molecule we are considering this as a PB. At 100 degrees centigrade, both are converting into the gases. Both are converting into the gases means, and that is also both are Here ethanol is volatile. Ethanol is here volatile. That means vapor pressure is going to be increases or decreases? Total vapor pressure is going to be increases or decreases, ma?
Increases, sir.
Understand, sir.
Very good, Sirisha. Vapor pressure is going to be increases because of alcohol. First, it is going to be evaporate fastly. Then it is converted. It causes so much vapor. Then it causes the pressure here. That pressure only we can call as a vapor pressure. After that, water also it is converted into the gas. That gas is causes some pressure on the surface of the liquid. So individually, if they are having the pressure, partial pressures we can call. If you add together, that means the total vapor pressure is, that means P is greater than that of the PA plus PB. Individually, if you see, means they're having different value. Together, if you see, means the total pressure is equal to greater than that of the PA plus PB. Okay, and volume in this one. Now only you told that, sir, boiling point temperature is increases. If the boiling point temperature is going to be increases, means delta H value it is greater than 0 or less than 0. What about the boiling point temperature? Boiling point temperature is going to be increases. The boiling point temperature is going to be increases means delta H value is greater. If the delta H value is greater, means the given reaction is exothermic reaction or endothermic reaction. Delta H is greater than 0 means what, ma? Delta H is greater than 0 means it is Samhita, Srisha, Sai Akshit, Ritu, Aditi. Good, good. Tanish is absent. Right now? Right, man. Now you can check it out. Okay. So delta H value is greater than 0. Delta H value is greater than 0 means then the given reaction is endothermic reaction. Okay. What is the endothermic reaction, Sirisha? Endothermic reaction. What is the endothermic reaction? Aditi, what is mean by the endothermic?
So something that needs energy or absorbs heat in.
Heat absorbs. Endothermic is nothing but heat absorbing. Here only clearly it is there. Because of ethanol, before that 70 degrees it is there. But after here from 70 to it boils at 100 degrees. That means it absorbs the 30 degrees centigrade of the temperature. Absorbing of the heat energy is called as an endothermic reaction. Okay. Then volume also is going to be increased. Volume also, the change in volume delta V mix also it becomes as a greater than 0. Okay. Now let us see next one. So what are the examples of? Okay. So what are the examples of positive deviation non-ideal solution? So what are the examples? Means once you check out, ma. Here what are the examples we are having means here? Now acetone and ethanol. Acetone and ethanol. Acetone and ethanol is the example of positive deviation non-ideal solutions. And the mixture of acetone and carbon disulfide, it is the example of positive deviation non-ideal solution. And other examples, water and methanol, water and ethanol, carbon tetrachloride toluene, carbon tetrachloride chloroform, acetone and benzene, carbon tetrachloride and methanol. All these are the examples of positive deviation non-ideal solutions. Got it? All these are the examples of positive deviation non-ideal solution. So just you remember this value, these examples. Again, somewhere we are using these examples. So what are the examples of the positive deviation non-ideal solutions? So one is the acetone and ethanol, acetone and carbon disulfide, water and methanol, water and ethanol, carbon tetrachloride and ethanol, carbon tetrachloride and chloroform, acetone and benzene, carbon tetrachloride and methanol. Got it? And we'll discuss about the negative deviation non-ideal solution. Actually, we can represent graphical representation also, it is there. Okay, next we'll show the graphs later. Okay, I will show the graphs later here. Otherwise, can I write here? Graphs here only. But these also, what are the positive deviation ideal solutions are there, negative deviation non-ideal solutions? Everything we can represent with graphs also. Sir, how we can represent means here, we are taking pressure on the y-axis and mole fraction values we are taking on the x-axis. Okay, so actually you'll get like this in this one. Okay, here in this one, x is equal to xa is equal to 0. If the pressure is going to be increases, what about my here mole fraction also is going to be increases or decreases according to the Raoult's law? What is the Raoult's law? What about the vapor pressure? Vapor pressure is directly proportional to the mole fraction of the component. Okay, so vapor pressure is directly proportional to the mole fraction of the component. Initial concentration, initial how much it is there means mole fraction means 0. If the this side it is going to be increases means by reaching until here xa it becomes as a 1 only. If xa it becomes 1 means here, then let us see how we'll get the graph means here. So we'll get as like this. Mole fraction is increases, their vapor pressure also is going to be increases. Okay, this one is vapor pressure. Now, if I take XB this side, XB is equal to 0. If XB is equal to 0 means here, if the mole fraction is going to be increases means vapor pressure also is going to be increases now. Vapor pressure also is going to be increases. Okay, now this we are going to consider it as a PB and this we are going to be considered as a PA. Sir, how we can calculate the total pressure means we can draw like this here. This P is equal to PA plus PB. Actually, this is the Raoult's law. Whatever the lines I wrote here, that it represent as a Raoult's law. But we are applying the heat energy. Heat energy means curves you will get like this. Okay, here also you will get like these curves, and here also you will get as a curves like this, and this side also is going to be increases. Okay, if it is above 1 it is there means that it represent as a positive deviation non-ideal solution. That means based on the graph also we can say either the given graph is represent as a positive deviation non-ideal solution or negative deviation non-ideal solution. So positive deviation means it absorbs the temperature. Whenever it absorbs the temperature, pressure is going to be increases. If the pressure is going to be increases means the graphs are it will come like this. Okay, all of you understand? You understand or not? Graph.
Yes, sir.
Okay.
Yes, sir.
Next one. So we'll go for the negative deviation non-ideal solution. Okay. So what is meant by the negative deviation non-ideal solution? So for the negative deviation non-ideal solution, let's see. In a solution, here statement they had given, 5th point they had given. In a solution, solution means containing the solute and solvent. Na? Okay. In between the solute and solvent, they have a strong intermolecular attraction forces. Okay. Solution is having the strong intermolecular attraction forces than the top solute and solvent. A is nothing but solvent. B is nothing but solute. Okay. Sir, what are the examples for this one means? Let us see. Methanol and acetic acid are water and nitric acid, water and HCl, chloroform and diethyl ether, acetic acid and pyridine, chloroform and benzene. Here, by seeing this one, I'm getting as a some small logic. Acetone and aniline, both are non-polar or polar molecules. Acetone and aniline.
Non-polar, sir.
Very good, Sirisha. Both are non-polar only. Okay. And water molecule and nitric acid, both are polar or non-polar?
Polar.
Both are polar molecules only. Okay, so water and nitric acid, acetone and aniline, acetone and chloroform. Acetone and chloroform also it is a non-polar molecules, organic solvents we can call. Okay, dipole moment value is very less. Those are we can call as a organic solvents. Okay, and these are polar molecules. So they have a strong intermolecular attraction forces. They have a strong hydrogen bonds here. Okay, so that's why solutions are having strong intermolecular attraction forces than that of solute. Now, if you see clearly, actually HCl it is there. First of all, HCl is the gas or liquid ma. Yesterday also we got the doubt. HCl. Is HCl is the gas or liquid? HCl.
Liquid.
HCl is the gas.
Gas.
Hydrochloric acid is gas. Okay, it is highly volatile gas. Whenever it dissolves in a water, so whenever it dissolves as a water, it becomes as a non-volatile. Okay, it becomes as a non-volatile. Okay, so why it is not why it becomes as a non-volatile means here it has a strong intermolecular attraction forces in between the solute and solvent. Okay, before that it is highly volatile. Whenever you dissolve in a water, it becomes as a non-volatile. That is why it is non-volatile means because of strong intermolecular attraction forces. Whenever they're having the strong intermolecular attraction forces means that kind of solutions are called as a negative non-ideal solution, negative deviation, non-ideal solutions. Okay, so sir, how we can say means let us see, ma'am. So we are taking as a vapor pressure on the y-axis and mole fractions we are taking on the x-axis. Okay, so here I'll give one clarity. What is the clarity means here, sir? First we are taking as an ideal solution. What is mean the ideal solution means here? So with the pxa, okay, so xa is equal to 1 and sorry, xa is equal to 0. While reaching here xa it becomes as a 1. In this side we are taking as a xb. Initial value of the xb is equal to 0 and xb is equal to 1. When it becomes as a xb means here by the pressure is going to be increases. This is a generally we got here. And total pressure we are representing it like this here. Total pressure. Total pressure. This is the total pressure that we can write as a P is equal to PA plus PB. And this we are considering it as a PA value and this we are considering it as a PB. Now in this one my question is, before that what I told, HCl is highly volatile. If it is volatile means the vapor pressure is having the more or less for the HCl. HCl is
Less, sir.
HCl is highly volatile. If it is highly volatile means before dissolving in a water, the vapor pressure is more or less. HCl is containing the more vapor pressure or less vapor pressure before dissolving in the water. Sirisha, Aditi, Ritu,
Yes, sir.
is pure HCl is having the high vapor pressure or low vapor pressure? Pure HCl. Pure HCl. Ritu, Aditi is giving us some answer.
Sir,
Aditi,
high
what?
vapor pressure.
High vapor pressure, very good, Samhita. Okay, so because of HCl is the volatile, so that's why it is having high vapor pressure. Now, when HCl is dissolved in a water, vapor pressure is going to be increases or decreases? Samhita, after dissolving into the HCl, vapor pressure is increases or decreases?
In water, sir, decreases, sir.
Very good, man. Decreased. Okay, it is decreased. If the decrease means we can represent Arrow marks are we can represent like these. Okay, so below the plane we can write here. We can write like this. This is the one, and PB is also is going to be decreases. Okay, so whenever it is decreases means that it represent as a like the. So this given graph is represent as a negative deviation non-ideal solution. So this graph is represent as a positive deviation non-ideal solution. Okay, for the negative deviation non-ideal solutions, delta H value is less than 0. Less than 0. They releases the heat energy. Whenever you dissolve, whenever you are going to dissolve sulfuric acid in water, they releases the heat energy. Nitric acid in water, they releases the heat energy. Okay, so all this one we can do in lab, ma. So that's why I'm asking either practicals are done or not. CBSE student, they got the practical data. I think so. Jan 1st onwards, February 14th is the last practicals. You all are state board or CBSE, ma? Aditi?
So we have practicals like next year for CBSE.
For
Sir,
you.
I am state.
Okay, state. Then remaining other?
State, sir.
State, sir.
Most probably
State,
state.
sir.
Okay. I think so. For you in the month of February, you know, Feb only, na? Practicals.
Yes, sir.
Yeah. So, but CBSE already they started. Jan 1st week. Today only we got the meeting. Okay, so they're telling that clearly they announced January 1st week onwards up to February 14th, CBSE practicals are there. Okay, so if you do the practicals, we have to prepare some solution. There we'll observe all this one. We want to prepare the dilute solution of the sulfuric acid. How we are preparing as a sulfuric acid means we are taking the water in a one container. In that only we are adding as a sulfuric acid. Whenever you add the sulfuric acid, if you hold your glassware means it becomes as a hot. Similarly, sodium hydroxide is there. We have to prepare the aqueous solution of the sodium hydroxide. So whenever you place the sodium hydroxide pellets, it will be there. So if you place in your water and if you stir that one means the whole water it becomes as a so hot. Why it is becoming as a so hot means whenever it is reacting with the solvent, it releases the heat energy. Releasing of heat energy is called as a exothermic nature. So that's why delta H value it becomes as a 0. And volume also, ma. Okay, so volume also. So volume also what happened means here, volume also change in volume. Delta V mix also it becomes as a 0. Delta H mix also it becomes as a less than 0. Got it? Okay, so all these are about ideal solutions and non-ideal solution. Point number 1. Sir, how they'll ask the questions in the NEET level or JEE level examination? Okay, so first of all, based on the examples, they'll give some 4 examples. Okay, so based on that one, you have to find out which of the following is the ideal solution. That means you have to find out. For that one, you have to remember the examples. Second example, for ideal solution, what about the change in enthalpy value? What about the change in enthalpy value for the ideal solutions? For ideal solutions, ma, change in enthalpy value. Ideal solutions. Here only it is there, na? Where we got?
0, sir.
Change in enthalpy value is equal to 0. For non-ideal solutions, what about the change in enthalpy value? For non-ideal solutions, what about the change in
More than
enthalpy value? Ma?
More than 0?
I'm not asking either it may be more than 0 or less than 0. What about the change in enthalpy value for the non-ideal solutions? Options. Delta H is equal to 0. Delta H is not equal to 0. Okay. So both, none of the above. What is the answer?
Delta H is not equal to 0.
Right? Now, my question is, for which of the following solutions are having delta H is greater than 0? Once again, I'm repeating the question. Which of the following solutions, for which of the following solutions, delta H is greater than 0? Options. Ideal solutions, positive deviation, non-ideal solutions, negative deviation, non-ideal solutions, none of the above. Can I repeat once again question?
Yeah, sir.
Okay. Which of the following solutions contains delta H value is greater than 0? Options. What are the options means? Ideal solutions. Second option, positive deviation, non-ideal solution. Third option, negative deviation, non-ideal solution. Option D, none of the above.
Non-ideal positive deviation.
Very good, Ritu. Positive deviation, non-ideal solutions are delta H value is equal to 0. Okay. So once again, my options are same only. My options are same only. Which of the following solutions AB intermolecular attraction forces are greater than that of the solute and solvent? Which of the following solutions are contained? Solution intermolecular attraction forces are greater than that of the solute and solvent. That is my question. Statement wise question. Options are same. Ideal solutions, positive deviation, non-ideal solutions, negative deviation, non-ideal solutions, and none of the above.
Negative deviation.
Sir, is it negative deviation?
To make it clarity, I'll write as here. So I think so you are getting confusion. Hope so. Orally, I'm telling that. Now my question is, what's the question I'm asking means here? AB is less than that of the AA and BB. Which of the following solution is containing this kind of arrangement? Options: ideal, positive deviation, negative deviation, none of the above.
Negative deviation?
Positive
Very
deviation.
good. Positive deviation. Here only it is that. Because of positive deviation under AB intermolecular attraction forces are weaker than that of the AABB. Same question slightly modified. If here AB intermolecular attraction forces are greater than that of the AA and BP, which of the following solution? Positive, negative, and ideal.
Negative. No.
Very negative deviation on ideal solution. And one more question. Okay. So what is another question means here? Water plus HNO3. The given example is related to ideal solutions, non-ideal solution, positive deviation, non-ideal solution, negative deviation, non-ideal solution. Water and HNO3. Make it fast, man.
Negative non-ideal solution, sir.
Very good, man. Negative non-ideal solution. So one more example, simple example only I'll ask. Okay. So water plus methanol, C2H5OH. C2H5OH is example of positive, negative, or ideal. Aditi, the given example is related to ideal solution, positive deviation, non-ideal solution, negative deviation, non-ideal solution. Lost N-hexane, N-heptane. N-hexane plus N-heptane. Sorry. N-hexane and N-heptane. Example of ideal solution, positive deviation, non-ideal solution, negative deviation, non-ideal solution. Okay, anyway, once you read and you can practice the questions.
Sir, it's ideal solutions, sir. For
Very good.
N-heptane.
Samir, it is correct only. N-hexane and N-heptanes are so positive deviation, non-ideal solution. So once you read this concept also very important for the exam point of. Okay, and the next one is azeotropic mixture. Okay, azeotropic mixture. Now, what is mean by the azeotropic mixture? Azeotropic mixture. Azeotropic mixture. So what is mean by the azeotropic mixture means here? Mixture of components. Now only I told that. Sir, what is the best example for the azeotropic mixture? Means here water plus ethanol, C2H5OH. Okay, and water plus HCl, water plus HNO3, water plus HNO3. Sir, first why you are giving the example means first of all to make you understand. So what I told that here the boiling point of the ethanol is 60 to 70 degrees centigrade. Is it right? Water boiling point temperature is at 100 degrees centigrade. Whenever you dissolve the ethanol in the water, the boiling point temperature of the mixture it becomes as 100 degrees centigrade. Got it, all of you? At 100 degrees centigrade, both liquids are they act as a true solution. Both components are they act as a true components. They cannot be separated by the methods, distillation methods. These two cannot be separated by distillation method. Got the point or not? Is any possibility is that both are boiled at 100 degrees centigrade means is any possibility is that to separate that one? Once you dissolve the alcohol in the water means it is not possible to separate the mixture of components into individual components. Okay, that kind of mixture only we can call as an azeotropic mixture. Got it, all of you? The mixture of components which acts at one particular boiling point temperature, they act as a true components, true solutions. They cannot be separated by the distillation method. That components only and that mixture only we can call as a azeotropic mixture. Okay, again azeotropic mixture is classified into two types. Sir, what are the two types of the azeotropic mixture? It is that means here maximum boiling azeotropic mixture, and second one is minimum boiling azeotropic mixture. Okay, sir, which one it shows the maximum boiling azeotropic mixture? What are the examples of the maximum boiling azeotropic mixture? Means here, sir, negative deviation, non-ideal solutions. Negative deviation, non-ideal solutions are they shows the maximum boiling azeotropic mixture. Okay, and minimum boiling azeotropic mixture. What are the examples of the minimum boiling azeotropic mixture? Means all positive deviation non-ideal solutions are they show us here minimum boiling azeotropic mixture. Sir, what are the examples? Means in this one, first for negative deviation means we can write as a water